Since we've covered colors in CSS, let's talk about units now. The basic units in CSS are pixels. The screens of our monitors are characterized by a certain resolution, which is the density of pixels on a screen. The Full HD screen is 1920 pixels wide and 1080 pixels high, and we as the web developers can manage these pixels. Pixels are a fixed unit, in other words, absolute. If we set the width of an element to be 500 pixels, that element will always occupy that number of pixels. So on a computer monitor, it can be about a quarter of the screen width, and on the smartphone, it can be the entire width of the screen. It all depends on the resolution of our screen, which is how many pixels it fits. Note that we can use pixels as the units for many different properties. Here you have a picture of what I was just talking about. Imagine the top screen is the computer monitor screen, and the lower screen is the smartphone screen. If we specify the font size of the top text to be 20 pixels, and the bottom text to be 50 pixels, the effect will be as you can see on your screen. These texts will always be the same size. As a result, they will take up more space on a smartphone because the smartphone has a smaller screen. By setting pixels as a unit, elements do not adjust to the screen area. They remain at the same pixel size all the time. Here we will see it even better. We set the width of the yellow element to 300 pixels. We have moved this element away from the top and the left edge of the screen by a 50 pixel margin. Below you can see what this element will look like on a computer monitor screen and on the smartphone screen. This element looks exactly the same on both screens and it is exactly the same size. But on a smartphone it takes up a much larger area due to the screen size. Where we can use pixels, most often we can also use other units as a value. For example, rem, em, percentages, or viewport height. We will learn about all these units in this course. For now, just know that pixels are the only absolute unit. The other units are relative. But relative to what? That's what we are going to learn in this course as well. The first relative unit is the em unit. It refers to the parent element. The font size of our div tag is 20 pixels. If we did not add anything else, the p and the span elements would inherit this font size from their parent. But we specified the font size for the p element as 1em. 1em means one value of the parent element. So it's really 100% of the value of the parent element. The same value. So in this case, it's also 20 pixels. But we set the font size of the span element to be 0.8em. This is again 0.8 of the parent value. That's 80% of the parent's value. The parent of our span element is the p element. The p element has 1em of its parent, so it's 20 pixels. So the font size for the span element will be 20 pixels times 0.8, or if you prefer, times 80%. That is 16 pixels. So we already know that the em unit relates to the value of the parent element. But what if the parent doesn't have a specific value? Then this unit relates to the HTML element itself, which as you know must have a default value set for all the browsers. Now let me show you this in practice. I've prepared a simple document, which you can see right here. We have a simple basic structure of the HTML document right here. And in our body tag, all we have is a p tag with a text in it and the h1 tag with a text in it. Now let's open this document in Firefox Developer Edition. Just like this. Let's open our DevTools. Let's go to the Computed tab, which we can see right here. Let's click it. We can see that we have no CSS properties found, so it's empty. So now let's click this option right here, so we could see the browser styles, which are default styles. Let's click it. Here we got all the default styles for this browser. which are most likely the same for all modern browsers. Here we can filter our styles. So let's search for a font size property. And as we can see right here, we got our font size set to 16 pixels. And it's a property set to the HTML element, so it would be inherited to all the elements inside this HTML document. Of course, if we don't add our styles, our properties, for example. So if our elements have only M units and there are no defined pixels for any parent element, our M units will refer to the HTML tag, which is by default set to 16 pixels for the font size property in all modern browsers. We can check it if we want. Let's pick our selecting tool right here. Let's mark our P tag. You can see it's the same 16 pixels. Where our H1 tag, for example, is set to 32 pixels because we know that the H1 tag has its own default properties. But all the simple tags like the P tags, span tags, div tags, they will all inherit 16 pixels of font size from the HTML main element. So as I showed you, the H1 tag, which we can see right here, does not inherit this property, and it has its own font size, which is 32 pixels, which you can see right here. And now let's take a look on the H1 properties in the official specification, where we have the H1 tag and we have its font size specified to 2M. 2M is 2 times the parent value, which is 200% of the parent value. And as we know, the parent of the H1 tag is the body tag, which of course inherited its font size from the main HTML element. So it would be 16 pixels. So 16 pixels times 2 would be exactly 32 pixels, which we can exactly see right here. This is exactly how it works and how it is specified. Now you don't have to remember it or be able to count it on the go. I only show this to you so that you know where these conditions come from. The only thing worth remembering for now is that the default font size for the main HTML element is 16 pixels. This will make it easier for you to use the relative units such as the M unit. Now let's go to our Visual Studio Code. Let's make it full screen, just like this. Let's create a style tag in our head element. Let's add some CSS rules. For example, for a P tag. And let's set a font size to 3M. Let's save it. Let's go to our project. Let's refresh it. We can see the changes on our screen. Let's change the zoom a little bit. Let's mark our P tag like this. And now you can see that the font size for our P tag is 48 pixels because we set it to 3M units. 3M equals 3 times 16 pixels from the main HTML element, which is exactly 48 pixels. And we can see when we go to the rules tab right here that we set font size to 3M for our P tag, which will be computed by the browser to 48 pixels, which we can check in the computed tab. Let's go to our Visual Studio Code once again. Let's create a new rule in our style tag for the body tag this time. And let's also set our font size, this now to 1.15 M. Let's save it. Let's check it in our project. Let's refresh our website and you can already see the changes. Let's mark our body tag like this. Let's go to our rules tab. We can see that our body tag has its font size of 1.15 M, which will be computed by the browser to 18.4 pixels. Because it's computed like this: 1.15 times 16 pixels from our main HTML element equals 18.4 pixels. Of course, it will be rounded by the browser to 18 pixels. And now we can see that the font size of our P element also changed. Now it's 55.2 pixels, which will be rounded to 55 pixels. Because now it's still 3M, but since our body has 1.15 M, it won't be 3 times 16 pixels, but 3 times 18.4 pixels, which is exactly 55 and 2 pixels. Because the M unit is relative to the parent element, and the parent element for the P tag is the body tag and not the HTML tag. So keep that in mind, that the M unit refers always to the parent element. And it's the same situation with our H1 tag, which we can mark right here. In the rules tab, we don't have any custom rule for it, but you may see that it refers to its parent element, which is the body tag. And when we go to the computed tab, you can see that the font size for H1 tag also changed to 36.8 pixels, because it's now 2M of the body font size, which is bigger than the HTML font size, multiplying it by this value, and then the font size of the H1 tag increases as well, as we can see right here. Remember that the M unit always refers to the parent element. So now we can see on our slide that none of our elements is specified with pixels to its font size. But we know that the main HTML element has its font size set by default to 16 pixels. So now our div tag, which has its font size set to 2M, would be exactly 2 times 16 pixels, which would be 32 pixels. The P tag has its font size set to 1M, so it would be also 32 pixels because it refers to its parent element. And as we can see, the parent of the P tag is the div tag, which has 2M of its parent element, which is 32 pixels. So its child, which is the P tag, has value of 1M of its parent element, which is also 32 pixels. So then our span tag, which has its font size set to 0.8M of the value of its parent, which is the P tag, would be 32 pixels times 0.8, which is exactly 25.6 pixels, just as we can see it on this slide. Our main tag is set to 10 pixels. Then we have a div tag inside it, which is set to 1.1M, which will be 1.1 times 10 pixels of its parent element, which equals to 11 pixels. Inside that div tag, we have a P tag, which font size is set to 1M, which is exactly the same value as its parent element, which is the div tag. So it would be 11 pixels as well. And inside our P tag, we have a span tag, which font size is specified to 0.8M. So it would be 0.8 times 11 pixels of its parent element, which equals to 8.8 pixels, which be rounded by the browser to 9 pixels. Another relative unit is M. The difference is that the rem unit does not refer to the parent element, but always to the main HTML element. If our div has 20 pixels and its child, which is the P tag, has 1 rem, then 1 rem will not be 20 pixels. It will stand for as much as the main HTML element has. If we haven't assigned anything ourselves, it will be 16 pixels by default. Now I'm going to show you this in Visual Studio Code. Let's create a new rule in our style tag, this time for our HTML element. let's set our font family to Arial and our font size to 10 pixels. Let's save it. It's a very common practice to give the HTML element 10 pixels of the font size, so it's easier to use the rem units and multiply or divide this value. Now let's delete this body rule because we don't need it. Let's change the font size of our p tag to rem. And let's create another rule for our h1 tag where we specify our font size to 5 rem. Let's save it. Let's go to our Firefox. Let's refresh our page and we can already see the difference. Let's check the HTML element first, like this. We can see in the Computed tab that the font size of our main HTML element is computed to 10 pixels. And in the Rules tab, we can see we set our font size to 10 pixels. And we set our font family to Arial, which is visible exactly right here. Both the p tag and the h1 tag inherited this font family, so it's no longer Times New Roman. Now let's check our p tag right here. We can see that its font size is set to 2 rem, which is 2 times the value of our main HTML element. So it would be 2 times 10 pixels. So it should be computed by the browser to 20 pixels. Let's see it. And we can see it exactly right here. Font size of this element is 20 pixels. Let's go to the Rules tab. Let's check our h1 tag. And we can see we set its font size to 5 rem, which is 5 times the value of the main HTML element. As we know, it's 10 pixels. So it would be 5 times 10 pixels, which should be computed by the browser to 50 pixels. Let's see it. And we can see it exactly right here. So this is how it works. Remember that the M unit refers always to the parent element and the rem unit refers always to the main HTML element. It's very convenient because now all we have to do is to change the basic value of our HTML tag and the rest will adjust to this basic value. Let me show you this. Let's select our HTML element once again. Let's go to our Rules tab. All we need to do is to change the basic font size for our HTML element to, for example, 15 pixels. And you can see everything is changing proportionally to what we set in our CSS rules. Because all our elements refers to the rem value, which refers always to the main HTML element. We can change it to 0, 20 pixels, or leave it to 10 pixels. Because as I said, it's a common practice because it's easier for us to multiply and divide other values when we have 10 pixels as the basic HTML value. And we can work this way as a web developer. So what we can see on this slide is that our HTML main element has its font size set to 10 pixels. Then our div element has 1.8 rem as the value of its font size. As we know, it refers to the HTML element, so it would be 1.8 times 10 pixels, which would be exactly 18 pixels. And then we have a p tag, which font size is set to 1.6 rem, which also refers to the main HTML element. So it would be 1.6 times 10 pixels. So it would be exactly 16 pixels. Another relative unit is percentages. Polish proverb says that percentages are for smart people. because too much percentages is not healthy. A percentage is a very good unit, but it requires the knowledge of what it relates to, which makes it complex and sometimes difficult. Let us give ourselves a few examples. The first is the div tag that has a width of 80%. But 80% of what? In this case, it's 80% of the width of the parent element. Div is a block element. We will learn about it later. The default width value for the block elements is 100%. And it always applies to 100% of the width of the parent element. The same applies to the second example, the img tag, which by default always takes 100% of the parent's width, but we can of course change this value. In the next example, we have a p tag that has a font size specified to 30%. This also applies to the 30% of parent element's font size. If a parent of a p element, for example a div tag, has a font size specified as 50 pixels, then our div tag will have 30% of 50 pixels, which is 15 pixels. Next to it, we can also see the line height property, which determines the height of the line. We will also learn about it later on. This time 110% no longer means 110% of the parent element, but 110% of the font size value for that element. This is why I mentioned that the percentages can be problematic if we don't know the relationships they relate to very well. Another example is the article tag, the margins of which can also be specified as the percentages. Here the percentages again refer to the parent element, but in some cases using percentages won't work. In the last example, we specified the border as 2% for the aside tag. This solution will not work. Trust me, all of this will become clear in practice. So let's go back to our Visual Studio Code. Let's create a rule for our body tag once again. Let's set its font size to 120%. Let's change the font size of the p tag to 200% and the font size of our h1 tag, for example, to 450%. Let's save it. Let's see our project once again. Let's refresh the page and we can see the effect instantly. Now let's check our body tag. We can see we set it to 120%, which will be computed by the browser to 12 pixels because it's the 120% of the parent element, and as we know, the parent of the body is the HTML element, which has its font size set to 10 pixels. So our body has 120% of 10 pixels, which is exactly 12 pixels. Let's check our p tag, which is 200% of its parent element, which is the body tag, which will be computed to 24 pixels. And the last thing is our h1 tag, which is set to 450% of its parent element, which is the body tag, which will be computed to 54 pixels. Now we can mark our body element once again. Go to the Rules tab, change the font size of the body, for example, to 10%, which you don't see anything at all at your monitor right now. But let's say, for example, 150%. And you can see the change in all elements because they all refer to the body, which is the parent element. So when the parent element is changing, all the elements inside it are changing as well. Let's go to our Visual Studio Code once again. Let's change something in our HTML code. Let's create a section with the div tag inside it. and with a p tag inside it. Let's hit enter. Let's type text in our p tag. Let's delete everything from our style tag. Let's create a new rule for our section. Let's set our background color to dark green, for example. Let's set its width to 600 pixels. Let's set its height to 400 pixels. Now let's copy this whole rule. Let's paste it below. Let's change the selector to a div tag. Let's change the color to, for example, yellow-green. Let's change its height to 300 pixels. Let's change the width as well to 500 pixels. Let's copy this again. Paste it below. Change the selector to a p tag. Let's change the color of the background to gray. Let's change its width to 200 pixels and its height to 100 pixels. Let's save it. Let's go back to our project in the browser. Let's refresh the page. And here we have the effect on our screen. This is our p tag, which is 200 pixels long and 100 pixels high with the gray background. This is our div tag, which is 500 pixels long and 300 pixels high with the yellow-green background. And our section, which has 600 pixels of its width and 400 pixels of its height, and a background color, which is dark green. We set those values to pixels, so these values won't change no matter how big or small our screen is, which is no matter how big or small our browser window is. Let me show you this. Let's close our DevTools for now. We have our browser window, and when I change the size of it, you can see that the size of our elements do not change. All we got are those scroll bars to see the whole element. So our elements are hidden, but they still take the same amount of space specified with pixels. So it's not responsive. It does not respond to the changes in the browser window size and does not adapt. But let's change these values to percentages. Let's go to our Visual Studio Code. Let's change the section width to 50%, our div width to 80%, and our p tag width to 33.333%. That's no problem for a browser to calculate it. Let's save the changes. Let's minimize our code editor. Let's refresh our page. And now, no matter how big or small our window size will be, section will be always 50% of that window. The div tag will be always 80% of the section, and the p tag will be always 1/3 of the div tag. And you will see it when I will change the size of our browser window. The height won't change because we didn't set it, but the width is now responsive because we use the percentages to set it. No matter how small or big our window is, the proportions of the width of these elements will be always the same. And it's computed by the browser all the time. Let's open our DevTools. Let's make it a little bit smaller. Let's mark our section, for example. Let's click it. We can see in our Rules tab that the width of this element is always 50% of its parent, which is the body tag, which is by default our browser's window. So we can see it's 50%, and it's computed to 315 pixels. But when we change the size of our window, like this for example, now you can see the width of this element is now 426 pixels because our window got bigger, even though in our Rules tab it's always 50%. So it's always calculated and computed by the browser in a go. Now you can see the width of this element is 122 pixels with a little leftover, but it's still 50% of our whole browser window. So as you can see, percentages are responsive. They adjust to the browser's window size, and that's very important for creating websites that should display properly on any device, such as smartphone and tablet with different screen sizes. But we will learn all about it later in this course.